Welcome to RCast, the official podcast of the RChain Cooperative. RChain is a complete concurrent blockchain platform designed for maximum efficiency at minimal computational and environmental costs by utilizing proof of stake. I'm Derek Barris, the Director of Content for RChain. We cover a range of topics on this podcast, from the foundations of blockchain in general to the specifics of RChain, including our foundational language, Rholang, as well as issues in calculus, governance, security, and the forthcoming businesses and dApp development on our platform. Please check out rchain.coop to learn more about our platform, as well as information on becoming a co-op member.
Today, I was hoping we could go over the Rholang 1.1 proposal so that people can kind of see what the features are and the rationale for the features. I was hoping that Artur would be on this call, but Kelly is very, very protective of his time right now.
I'm actually on the call. Hi there.
Oh, you're on the call! Hooray!
It snuck in.
Okay, well that's even better. It's what a pleasant surprise. Part of the reason I wanted Artur on the call because you have another proposal for the applicative extensions. And I wanted to go over those, after we go over the features that I've proposed, and because I'd like to give people a sense of how far we could go. I also want to encourage exploration. It's open source. People could take the applicative ideas and do a knockoff, like a prototype, and people could start to see what the advantages are. And so I'd like to go over those as well. How's that sound as an agenda for today?
That sounds perfect. And just let me say thanks for having me on again. And those questions that you posed right at the beginning is exactly what I wanted to hear about today anyway. So.
Awesome.
Yep.
Essentially, the Rholang 1.1 proposals have to do with providing support primarily for sequential computation. Rholang 1.0 was all about supporting concurrency and not necessarily making it easy to do sequential computation. What I've discovered from years and years and years is that if you give people a tool that's very close to what they're familiar with, they won't go and explore the corners that they're not familiar with. They'll stay in their comfort zone, and you have to kind of get them out of their comfort zone so that they can understand exactly what you're trying to say. And then after they've had some chance to really get a grasp of what the full scope and scale is, then they can move into things that are a little bit more familiar, but in this wider context. That's the rationale behind the way we've rolled out the Rholang design. These features are largely about making it easier to express certain kinds of sequential design patterns. So as with the last few talks, there are some slides that I'm speaking to. They'll be available on the podcast page.
Yeah, and I just wanted to add that, and you kind of summarized what I'm about to say, but I just wanted to kind of say it in a slightly different way. But yeah, giving people a new tool is essentially giving them a new way to think about problems. So I understand that, like, just kind of forget about the old way for a second so you can think in this new way, and then now introduce some features where it's like, but it can also do the old things that you're familiar with. So let's throw those features in as well. That totally makes sense.
Yeah, exactly. And I actually learned this the hard way when I did BizTalk inside Microsoft. I gave, the full suite and, discovered that because I also offered this way for people to stay in their comfort zone, they did.
Yeah, right.
Surprise. And then I watched the same thing happen with Scala, where Odersky did a very clever thing, which is that he made it possible to program in a very Java-like way inside Scala, which was, really smart marketing, because a whole bunch of developers could kind of come over to Scala, jump on the Scala bandwagon, but they were really still programming in a Java-like way. They weren't actually using functional design patterns. But enough philosophizing. I was hoping to jump over to the first feature, which is a new and improved for comprehension. In this proposal, we rejigger the syntax a little bit. So we're going to replace the old meaning of semicolon in the join patterns with an ampersand. And the semicolon will take on the meaning of sequencing. So the general form would be something like for, and then you have a bunch of pattern from channel, binding pairs. So, you have a pattern on the left-hand side of a binding arrow from a particular channel, ampersand, and then another one of those, ampersand, another one of those, yada, 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 and then semicolon. And the meaning is that all of those need to go at once, right? So you have to have bindings that match the patterns from each of the channels in parallel. And then sequentially you move to the next set of binding patterns, and then sequentially you move to the next set of binding patterns. And then also the source, so in Rholang 1.0, sources can only be channels. And now we expand the notion of source to be either a sequential or a synchronous request, meaning that the other side of this is probably an output that is waiting for an acknowledgement, or it can be a method call, in which case you're sending arguments in to the request, to the source, and then there's a well-defined return channel along which you'll get a result. So again, we've expanded source to be a channel or a synchronous use of the channel, or the channel as entree to an object via a method call. So those are the three different expansions in addition to this join and sequence pattern. Does that make sense? It's hard to explain it. If you look at the slide, it's probably easier. But Isaac, Kent, Artur, is that making sense?
Yeah, definitely. I wanted to maybe phrase it like just a little bit differently than you phrased it, and ask a question in phrasing it this way. So to me, it looks like aside from the name or source changes, the changes in the actual for comprehension are now we accept basically a matrix of listens, whereas before we were accepting essentially a vector of listens, right? And by listen, I mean the source pattern binding pair.
That's exactly right. And in each row in the matrix happens concurrently. And then when you go from one row to the next, that's in sequence.
Oh, so it would have to match the first row, all, however many of those listens would have to, have some pattern that matches. And then we would go on to the second one and repeat that process.
Yeah. So you're chunking in rows.
Yeah. Okay. And one more thing, the rows, do they all have to have the same length, or can they all be different lengths?
They can all be different length. Yeah.
Okay. Perfect. Great.
Essentially, we've talked a little bit about the general form. If I just specialize down to the case where we've got a single synchronous listen binding pair, so then the for comprehension would look like for pattern from X question bang do P. That's the shape of the for comprehension. And the question is, what does that mean? Can we give a translation of that? Now, it turns out that we can desugar that quite straightforwardly. We take the pattern and we expand it into a tuple pattern. The left-hand part of the tuple is going to be the original pattern, and the right-hand part of the tuple is just going to be a single variable, which has to be fresh with respect to P, and that's going to be the return channel. Imagine that what's really happened is on the other side of this for comprehension, we have a send, and the send is sending the data, and is sending a tuple where the data is going to match against the pattern, and it's sending a return channel, and it's hanging its continuation So it's now an output continuation pair, right? It's hanging its output continuation, which Rholang 1.0 doesn't have, on a for comprehension, which is waiting for a ping on the return channel. That's essentially what's going on here. And the mnemonic of the question bang part, it helps people understand what's going on. We're waiting for an output on the channel, and then we're going to poke back something that is hanging off of an a need for an acknowledgement on the return channel. So that's the basic shape. Again, I probably mangled the English description. The math is nice and crisp. It's a one-line equation for desugaring. Any comments from you guys?
Yeah, I have one question / comment, and that's basically the freshness of this name R that we're listening for. Is the reason that we want it to be fresh so that it doesn't also interact with that original continuation P?
That's exactly right. If you look at the math, the pattern expands from pattern to tuple pattern comma R.
Yeah.
Right. And so now you've got a binder for R. So if R were free in P, then you would capture it accidentally.
Right.
And you don't want to do that.
Yeah, that makes sense. So now off of that question, how do we ensure the freshness of this name R? I guess we just measure take the set of free variables in P and just make sure that it doesn't coincide with any of those or something.
That's exactly right. Rhocalc has all kinds of fancy tools for this, but you don't need those fancy tools. People have been doing this forever.
Yeah, cool.
Yeah. Good questions. Any observations or questions from Kent or Artur?
It just struck me. So basically, what we are doing here, correct me if I'm wrong, but it seems that X is basically a function channel. So we receive on the channel the arguments in the return channel, and the question mark bang receive is sugar for implicitly immediately responding to the return channel with an empty tuple or with a nil or whatever.
Yeah. So it's kind of making the for comprehension into a makeshift function. It's a function that has a void return, but it does have a return. That's another way of thinking about it. That's interesting.
Yeah. The thing that struck me is that there is actually no ordering between the execution of P and the callback that is being sent through R.
That's correct.
And
that's correct.
Yeah, and I'm not sure why would we want that. I mean, initially I thought that we have that sequencing.
Well, what you have is you have a guarantee that Q will only run after the data on X has been delivered and not before. But the ordering of P with respect to Q, they're running in parallel.
Yeah, makes sense.
All right, I'm going to move on to the next one. The other source expansion that we have is the X bang question and then some arguments. The simplest expanded for comprehension that uses this would be for pattern from X bang question, some arguments A1 through AK, close paren, do P, right? So that's curly braces P. And essentially the idea, what this desugars into is now we make we really do make a fresh R in the sense that we bind it with a new binder. So we make a new R, and then in the scope of that new binder R, we send on X all of the arguments A1 through AK and the channel R, because that's going to be the return channel where we're going to get information. We're assuming or making use of the idea that on the other side of X is a function-like thing, which is expecting some arguments and then will return a value. And so the R is the place where the value is going to be returned. And the convention is that the return channel comes at the end of the list of arguments, right? So if you've got some other return discipline, then you would have to wrapper that to get it to line up with this convention, which is, of course, not a big deal. But if you were, for example, using this sugar to layer over a library that maybe was a C library that you poked through into Java and then made available in Scala and then made available through Rholang, and if that thing used a different convention as a part of your wrappering, you'd have to get the convention to line up. So the arguments first and then return channel, and then you hang P off of the value that you're going to get back from R, and that value is matched against the original pattern. And so you're expecting the return value to be some data that matches against the pattern. If you get a match, then you'll release the continuation. Again, long-winded way of saying what's just one line equation in the spec. But any questions, comments, Kent?
Yeah, this makes a lot of sense. Like the sugar that you've introduced previously kind of works well with this sugar, or this could be like the send side, and then the other sugar would receive on X and then send back on the return channel, and P would get run, for example.
Yeah, that's right. So I mean, you're bringing up an important point. The way we're doing all of these different sugars is that you kind of have to make them all work together all at once. and that's that. You're absolutely right. So as we go through all of these different expansions, we'll see how they all fit together. Like, and in particular, the output side needs to be looked at. And this one, we're expecting it to line up with either something in Rholang that looks very function-like, or with a Rholang wrapper around something that's, actually a function in Scala. All right, so let's move on. The other piece of the puzzle is Isaac's idea of thinking of this as a matrix. So you've got these rows that are separated by semicolons, and in the column entries inside the row are separated by ampersands. That's a good way of thinking about that. The way you can think about the overall desugaring of the new and improved for comprehension is you get rid of all of the fancy sources first, and then you'll be down to things that are just ordinary channels as sources. And then what do you do? The way the desugaring works is it's actually a little bit more permissive than getting rid of them all at once. When you have, for example, a source in the method call style that's in first position of a row, you cons up the new return channel, and then you do the send, and you put that in parallel with waiting on the R. You can do this likewise for the other kind of source, and so then you can get down to just ordinary join patterns. All that's left with is the sequencing part, and so the next piece of the puzzle is, how does the sequencing work? And essentially all that does is do nesting. So if I have a row that's all just proper channel sources, then I can turn that into an ordinary join, and then inside of that one do the translation of the matrix minus the first row. Long-winded way of saying what's, again, a one-line equation in the spec, but anyone want to take a stab at explaining it a different way, so for our audience?
I can try.
Okay.
So you're saying we're going to desugar the sources first, right? So if there's a method call on one of those sources in the first row, then we can desugar that. And if there's one of the other special sources that we have, we can desugar that as well. until we're down to only names as sources on the first, vector of listens.
Yep.
And then we just turn that into a usual for comprehension that with all of those listens joined together, just like we usually have in Rholang. And then the rest of the listens in that matrix are just put into the continuation, basically. And we just have, another layer of this desugaring to do at that point.
That's exactly right. So at the end of the day, what happens is the semicolons turn into nested for comprehensions. So I think probably people who have experience writing Rholang, they feel really uncomfortable with the amount of nesting that they have to do in order to do just what would be ordinarily just be straight line code in a language like Java or Scala or something like that. And so it makes Rholang look really unwieldy. And what this is doing is it's providing that code compression. So we now have this mechanism to do similar kinds of straight line code approaches. And then you can see for yourself the kind of compression you get. The nesting structure that people experience in Rholang today is very similar to when you program in Node.js and you have this sort of callback hell where it's like you send a message and then you have this callback, and inside that you're expecting to send a message and have a callback, right? It's just that same kind of ugly, unwieldy nesting, rears its head in most, purely asynchronous programming patterns. And this takes away that so that you can get the kind of compression that you expect in ordinary straight line sequential languages. Yeah, nicely described, Isaac. Let's look at the other side. So we've been focused on the for comprehension side, but as Kent pointed out, there needs to be some massaging on the output side so that they line up with the for comprehension side. In the case, for example, where you have a source that's like a bang question, question bang. On the output side, we now have two new forms, and again we use the bang question signals or characters to signal or provide a mnemonic for what's going on. So dual to the question bang binding pattern in the for comprehension, we have a bang question semicolon continuation on the output side. So essentially what that's saying is we're going to send the value and then we're going to wait for an acknowledgement before we fire P. Intuitively, you just turn the sending of the value into sending of a pair, which is the value together with a return channel, so that people don't have to write semicolon 0 all the time. We also add in a period so you can say X bang question some value period, and what that means is you're expecting to get an acknowledgement that the value has been sent, but there's no code to run after that. So that's the extension. And then the syntactic sugar is, again, very straightforward. So if the desugaring of X bang question V semicolon P is just make a new R in send on X the tuple V and R star, and in parallel wait on R for underscore. So we don't really care what we get back because we just want to know that we got something back, if that's the acknowledgement part. And then we run the translation of P. So that removes all the semicolons from output expressions. And then likewise, if you have an X bang question V period, then that just turns into the desugaring of X bang question V semicolon 0. Anybody want to take a stab at restating that? Or any questions or comments?
Oh, so, well, my first comment was the desugaring of this X bang question, value, and then run P, sequentially afterwards, is really, really similar to the, for comprehension where the source is the X bang question. Uh-huh. And so I was wondering, there are some slight differences, and the one big difference is you don't have a specific pattern that you're listening for on that channel R. It's just anything comes through.
Yep.
And the other thing that I wanted to ask was, so in this case, we're sending a tuple. Is there an advantage to sending the tuple as opposed to just like the value V and the channel R, just like as two messages kind of?
Well, you have to send them together.
Okay. Yeah.
But how it's packaged is, there are a lot of isomorphic packagings.
Yeah.
I just took this most straightforward one.
Okay. Cool. The last question that I have is that value V, can it be, a list of values? Like I know typically in Rholang, I can send like 1, 2, 3, I can send several values all at once, polyadically or whatever you want to call it.
There's an obvious polyadic
right.
extension of this. That's correct. Yes.
Cool. Okay. That's what I was getting at.
Yeah. Good.
Awesome.
Very good.
So I just wanted to point out, like, there seems to be like a small desugaring complexity. I guess you don't have page numbers, but so between the slide that says removing receive sends and the next slide removing semicolons, essentially you want to put the rbang unit, I don't know if that's the right way to say it, but you want to put that in par with the desugaring of the next semicolon. You don't want to put it in where the P is on this slide that says removing semicolons.
That's right. So that's why I say that the safest way to do this is you get rid of all fancy sources in a row, and then you chunk the rows. Then you do the nesting. And that
Yep. Yes, that makes sense.
Yeah, but it's a good observation on your part. Yeah, thank you for that. So in the proposal, I actually work out an example calculation. I don't know that I'll be successful in sort of giving an English description of the calculation. Let me just observe that we've got a one-liner where you've got a for comprehension that's doing one of these bang question receive and then acknowledge from X, where it's receiving something on the receiving something that's going to be bound to M, and then a similar N is bound to something coming out of Y, which we also acknowledge, and then the continuation is to print on standard out, to send a message on standard out that M plus N is equal to the actual arithmetic sum of M and N. That for comprehension is run in parallel with sending 1 on X, followed by sending 2 on Y. So you get the sequential output part tested against one of these nested for comprehension. So it ends up being a one-liner to write the whole thing. Probably the first thing that people should look at is what it expands to in terms of Rholang code, because it's a compression of a factor of 4. And the other thing is that when you run the desugaring, you get an equational proof that the desugaring does exactly what we expect it to do. Right, so the desugared program provides exactly the semantics that we want from the initial program that we started with. That's really what's important and goes to the heart of the whole R-chain philosophy. It's correct by construction. The equational presentation of the desugaring is the proof of its correctness. I don't do the formal proof here. Rather, I do kind of a proof by example. If you run through this example on your own, you'll see that we literally have a formal proof of the correctness of the execution of the sugared program when it's desugared. And at the same time, you can see the extent of the compression that this sugar provides. We're starting to see some of the payoff of the whole RChain philosophy. The idea is we recognize that the community of programmers and developers writing Rholang smart contracts is suffering. They'd like to be able to write more compact smart contracts, and so we introduce some language features, and we provide an equational specification of the meaning of those language features, and that gives us a formal proof that if the compiler follows the equational presentation, then the compiled programs will be correct. That's the way I've wanted to do product level development for ages. I'll be honest, I was completely ruined after I was in Ottawa presenting on some research I had done at one of the OOPS laws, and I saw Samson Abramsky talking about linear logic. And so when I got home, I read his paper on computational interpretations of linear logic, in which he presents this kind of methodology. This was back in the late 80s. And I was completely ruined. It was like, I'm never, ever doing software again that doesn't have this kind of correct by construction approach to it. And so that, so that's what's informing what's going on in RChain architecture and design. But I've been mumbling on for too long. Any thoughts or comments from you guys?
Oh, I didn't think it was mumbling. I thought that was a great story.
If you guys get a chance, go over the calculation and see if it makes sense. I'm not sure that in a podcast format it would be easy to describe in English, but I would love for folks to take a look at the calculation and see exactly how it works out.
So I can take a real quick stab at trying to describe it, or at least trying to describe the point of showing the example. So basically, we're just listening on two channels in a joined fashion, and then using this kind of acknowledgement synchronization mechanism that we're building here into the syntax, and then doing one of those synchronized sends to each one of those channels sequentially even. But I guess maybe that's all I want to say about it.
No, that's exactly right. I mean, on the third page of the calculation, essentially what we're able to guarantee is that the COM event on X with the correct substitution must occur before the COM event on Y. You could formally prove that. The calculation shows that that's exactly what happens. You can take this as a template to kind of formally prove a similar kind of property for the sugar at large. Exercise left to the reader.
So actually, I have a question now that you said that, because that was a good point. So what's guaranteeing that the COM event on the X channel happens first is the position of the listen on that channel X, or is it the fact that it's the first send in the sequence of sends, or is it a combination of the two?
It's a combination. It's the way the new and improved 4 interacts with the new and improved output.
Okay, cool.
Yeah, and that's the trick, is that you have to improve them both.
Right. That makes sense.
I know that I've belabored the point about the compression, but there's more to it than just compression. The other thing is that we have kind of gathered up all of the uses of unforgeable names that are just about this kind of coordination and have no transactional import under some syntactic sugar. And so all of those could be marked and treated differently with respect to the blockchain semantics. In particular, they don't have to go through the same kind of consensus. In other words, you can lift this up a level, so the consensus is about the sugar and not about the desugared form, which means then that you don't have to hit the tuple space in the same way for the unforgeable names. So it not only gives us this ability to improve the expressiveness of the programs, it also gives us a potential very large win for performance. In general, you'll get better than 2x compression, and for certain classes of smart contract design patterns, you'll get a better than 40% improvement against the current semantics.
That seems like a pretty large load off of the shoulders of the validators. Just looking at it, I mean, I don't know a whole lot about how to, quantify that statement or anything, but it does seem like a lot.
Yep, I agree. Any thoughts from you, Kent or Artur, on the points that I'm making here?
I think on the language level, it makes a difference. What I'm thinking right now is essentially for the platform as a whole, the bottleneck is at the consensus layer. So it probably won't be a while until the language level efficiencies really shine through.
I think you're right about that, but every little bit helps.
No, I agree. Yeah, that's for sure.
Yeah, very good.
I would also add that the deconstruction of this syntax makes for a really nice way of implementing that, because basically when we discussed it in Wrocław, my first instinct was to not actually store the desugared form in the tuple space, just store the compressed high-level AST, and maybe desugar on the fly according to the rules that are presented in the slides. But we can go even further than that. We can have a direct interpreter of this high-level AST, which is going to bring the computational efficiency improvements that Greg was suggesting, was referring to earlier. I guess I like it as a language implementer.
Exactly. Yes, we're on the same page. We can execute the higher level language directly, but the nice thing is we don't lose the connection to the desugared form. We always know that if we need to, we can talk about it in terms of just like low level, simple operations. And so we don't have to take on any kind of technical debt or worry or concern that we didn't get the semantics right or anything like that, because we have a formal proof that it works. And the proof is the implementation in a very real sense. I want to blaze through the other features because I want to give Artur enough time to talk about the applicative stuff. So let me just be quick on this. We can also add let expressions. Anyone who's programmed in Java or Scala especially, they're sort of used to being able to say something like, val x, where x is some pattern, is equal to some variable, and then you do all the destructuring, semicolon, and then do p, right? So you have a binding for x in the scope of p, or a binding for all the variables in the pattern x generated by destructuring v according to x in the scope of P. So it's a very natural thing, and it gives a high degree of code compression, which is not currently available in Rholang without doing ascend. You can have two different kinds of let, where you have nested let. So you have let pattern 1 come from V, so that's going to create a binding for the destructuring of V with V1 with respect to the pattern 1, semicolon, yada yada yada, up to pattern M from Vn in P. But you can also do simultaneous. So that's nesting. You can also do simultaneous, right? So instead of semicolons, you use ampersands. And then the desugaring, you can do it either in terms of match. But I always think of since from my point of view, match is already syntactic sugar. I go down to the bottom. So the semicolons are nested send and receives, right? So you send on some fresh X the value, and then you wait on X and bind that to the pattern, and then so that's the first binding pair in the semicolon let, and then you recurse and do that nested. The other way around is to do it as a join, right? So you send all of the values all at once, and then you wait in a join on all of the channels that you've sent those values on, and you bind them to their respective patterns. So that gives you two different approaches, and that more or less corresponds to what you typically see in functional languages like Scheme, where you have either a nested let or a simultaneous let. It doesn't give you the recursive let, but that's really what contract is for. And Artur and I had a good discussion in Rholang. My original guidance was that the interpretation of contract as a persisted continuation was only a convenience, but that the better interpretation is to do that as a recursive let. Because recursion is better suited to modern computational architectures, and I think when we move to Rholang 1.1 implementation, and possibly even sooner, we will take that perspective. We'll move to that interpretation. They're interdefinable, but that one is better in terms of existing platforms like the JVM. Artur, do you have any comments about that?
Yes, so I just wanted to point out about the two variants of the let syntax. For me as a programmer, this is very promising in that I can leave guidance on the syntax level, which of the values can depend on each other and which cannot.
Yes.
So if I use the ampersand syntax, I assure that the values don't depend on each other, which is great.
Yeah, because now the compiler will go and check your intention.
And about the recursion, I think having a recursive let would be great, or some kind of recursive syntax that would allow us to have a term that can somehow refer to itself, somehow spawn a copy of itself. A couple of days ago, I mentioned in our internal channels an idea for a syntax sugar where we would have a receive from the underscore channel, and the underscore would resolve to the name of the receive that we are in, which I'm not sure if it sounds at all, but I guess
I've been thinking about it. I think there's some issues, but I'm still thinking about it.
I wouldn't be surprised if there were issues. Anyway, having some more direct way of expressing recursion would also allow us to be more efficient in our contracts.
Yes, agreed.
Yeah.
Agreed. Yeah, 100%. It also gives you, in the same way that we can kind of execute the higher level language with respect to the new and improved for comprehensions and output, we can also execute the higher level language with respect to these let constructs. And so that gets us performance improvements. Because again, there's some fresh name generation going on here that doesn't have to hit the tuple space. So we can get some improvement there, and we don't have to get consensus about that. So that's an improvement. But now let me turn it over to Artur to kind of tease people to what we might do with an applicative notation.
Haskell has this thing called first of all, it has do notation, which is also reflected in Scala as for comprehensions. I don't really have a formal thought about that, but my impression is that Rholang's for comprehensions the extended ones in the 1.1 syntax are also kind of related to the do notation. In them, basically having a way of sequencing computations. And also another similarity is that the new improved for comprehension, what it does, it takes a bunch of nested receives and makes them into a not nested block structure, if that makes any sense. When working on the RevVault contract, especially in the area of error handling, this nestedness of Rholang syntax, whenever we basically do a method call, which I used to call the method call triad, which consists of the new name being declared, then a receive being declared, and a send being done to that name on which that receive listens, and which is the name declared in the new, and which is actually all covered in the bang question mark syntax. Because of the triad being nested over and over again, I went to workarounds where I embraced a convention where instead of taking values, my methods, my combinators would take channels from which they would receive the values. So that would strip off at least the receive from the triad, from the method called triad. And then I would take all those names being declared and put them all on top, and suddenly I too didn't have nested code. I had linear code. That's kind of a hack, but what that led me to was realizing that this is actually quite similar to how do notation works. At the same time, it was different in the code that I had. It wasn't actually executing completely sequentially. It was executing as parallel as possible because of how Rholang is constructed. And that led me to the realization that this seems similar to Haskell's applicative do. So Haskell's applicative do, if you're familiar with do notation, the sugaring of do notation is straightforward. It doesn't depend basically on anything. There's like two rules. When we're at the end, we do a map, otherwise we do a flat map. But that also means that regardless of whether the next step of the do computation depends actually value-wise on the previous, or if it doesn't, it all is being executed in sequence. And in some cases, that's wasteful. And what Simon Marlowe and Simon Peyton-Jones and also Edward Quaid, so basically all the saints of Haskell, came to the realization that this can be done better. And in Haskell, they propose this applicative do, desugaring, which inspects the dependencies between the sub-expressions of the do block. And whenever it's possible, they use the applicative semantics. They use desugaring that basically tuples the computations, kind of similar to our ampersand operator in the Rholang 1.1 syntax. And while listening to you guys today, I realized that my proposal is actually in there. It's in the ampersand. So that's being executed in parallel. The only issue I would have with that is that in my original proposal, what I did was, well, first of all, I only focused on the method call syntax and having it run in parallel. Greg's proposal is much more formal and much more complete. It being complete leads to new discoveries like the one I mentioned about let variants. But what I would consider doing is maybe refraining from providing the sequential semantics just for a little bit more. Because if sequentiality is needed, one can enforce it with the valued flow. And when it's not, well, there is always the temptation or the risk of using the semicolon spuriously. So
the thing I liked about your proposal is that you end up with a data flow sublanguage in the for comprehension. My proposal is forcing people to make some hard commitments in syntax about where there's parallelism and where there's sequentiality. Whereas in the applicative side, they can kind of not say what they mean, but there's enough information in the syntax to work out the data flow dependencies, and then it will just do the right thing.
Yeah, and I think that's actually what is going to happen if we across the ampersand sides can depend on each other. So that's kind of a difference. But other than that, yeah. So if we say allowed for not having the semicolon at the end of the new for comprehension syntax, at the end of the row, well, then that would mean let's for a while assume that would mean that the order of execution can be arbitrary and is only determined by the data being used. Mm-hmm. And yeah, that behaves, I would say, very much like Haskell's applicative do.
Yeah, exactly right. And so that's why I was really delighted by your proposal, was precisely for that. And so and this is where I think we should let 1,000 flowers bloom, in the sense that, I mean, why I mentioned at the top of the hour was just that I think people should go and start doing some experiments, right? You know, I would really like for a group to go and code up demonstration of the applicative approach, precisely because of this data flow potential. The other aspect of it, which you didn't touch on, but which I'm quite keen on, that there's co-do notation as well. There's the comonadic side of this that we haven't discussed, that would be great for streaming applications. So, you know, if we can provide applicative, data flowy kind of language, and at the same time, dual to that, provide the comonadic co-do notion, I think that is some rich area of language investigation, and it all comes out of this understanding that the monads are the new objects, and monads and comonads are the new object orientation, and people should be thinking that way. And the right sugar, the right syntactic framework for monads and comonads are this sort of for comprehension, do notation, applicative gadgetry that we don't know how it all balances out exactly right. And that's why I really, you know, like if there are courageous and intrepid community members who want to go and explore this stuff, we need lots of people exploring it. And this is really exciting, cool stuff.
Yeah, at the same time, so one of the benefits of having that syntax applicative by default would obviously be parallelizing as much as it is objectively possible. At the same time, from the community member's perspective who is to implement that, there's not a single best way to desugar applicative do. So that's kind of a tricky thing to do. And I would say that that's even more points to your proposal, because your proposal has a very direct and straightforward desugaring that is easy to implement. And with applicative do, that's, I'd say, no longer the case.
Well, yeah, at least for now. But I have a feeling that if someone goes and does it, we can find we can find a data flow semantics that makes the most sense, at least in this setting, which is why I really wanted to have this conversation.